Welcome to the 18th video in our series about Unix tools. In this video, I will show you more about the regular expressions used for patterns in the grep command. In previous videos, we have used globbing for patterns of file names. The shell explains the glob pattern to create a list of file names that match. This is called glob expansion. We learned that star matches anything and question mark matches any single character for those glob patterns. Regular expressions use the two symbols in a different way, together with many other symbols. Unlike globbing, regular expressions have been used by many tools, and each has its own distinct dialect. While regular expressions are reasonably easy to understand, using them can be tricky, since you must use different dialects for different tools. Today, most people group the dialects into three groups: basic regular expressions, extended regular expressions, and Perl-compatible regular expressions. Those are listed in order of complexity. Completely learning and using advanced regular expressions, like the PCRE expressions, is outside the scope of this course. However, we can learn to use some basic regular expressions in this course. So, let's get started. The period matches any single character. If you want to match an actual period, you need to use \period instead. The star for regular expressions says that the previous thing is repeated 0 or more times. The plus says the previous thing must occur once but can be repeated 1 or more times. The question mark says the previous thing is optional, 0 or 1 time. And then you can do grouping. Grouping is done with parentheses. So let's start with some simple examples. In the first column, you'll see the regular expression pattern concept. This is not the actual syntax, it's the concept. And on the right, it shows you what would be matched and what would not be matched. So you need to spend a little time and read this. You can hit pause on the video. But how do you match something like a top-level Python function definition? We had a simple solution in the previous video, but it's not really good enough. We learned that you can anchor your expression at the beginning with a hat character, which is Shift-6 on most keyboards. And you can also anchor to the end of the line with a $sign. If you want to, and that's a Shift-4 on most keyboards. So if you want to match a top-level Python function definition, you would start with this pattern, which is what we used in the last video. But what if someone has used tabs instead of spaces? So what if someone has def high, but the character between that F and that H is a tab? When you just use cat, you won't see it. And if you use nano, you won't see it. So Python will accept the tab as the separator. But our pattern won't match it because it's looking for a literal space. And so what can you do? Well, it turns out in regular expressions, you can use square brackets. And inside the square brackets, you can list characters. And what that means is A followed by 1 or 2 or 3 followed by BC, and that's going to match A1 BC, A2 BC, A3 BC. So you could use the anchor and then DEF and then this set of characters, which includes space or tab. I've used #I to represent the tab character. It's traditional on Unix systems. Okay, that would work. Now, what if we want to match one of two different things, like cat or dog? So we want every line in file name that has either cat or dog or maybe both. And you can do it like this. You use the pipe as the or, but you have to put a \/ in front because otherwise it will look for the literal pipe character. When would you use this sort of OR sequence? Well, many people writing documentation make the mistake of duplicating words like the or of, and they don't notice it because proofreading your own document is difficult. It turns out we can use the pattern grouping, the parentheses, as shown here. We're looking in the file CRUD with the grep tool, and we said we look for the pattern THE followed by \S, which turns out to be a special name for this, and then \1, which says the first pattern that we captured, which was the. So this looks for the space the or the tab the. And that's explained in this file. Again, hit pause on the video, read that text, and then come back. With the knowledge we have now, we can do a better job of looking for function definitions. And I forgot the hat because I'm an idiot. So let me put the hat to make it a top level. If you don't put the hat, it will also get methods that are inside objects or nested functions. So let's put the hat in there. And this says you must start the line with DEF followed by a space or a tab, and then your function name must start with a letter, anything from uppercase A to Z or lowercase a to Z, and then it can be followed by the same thing or an underscore. And I don't include digits here. This is not the final solution, but this is a pretty good start. And then I say after that first letter, you can have 0 or more other letters or underscores. And this shows you could end it with an underscore. Again, this isn't a perfect pattern, but it's a good start. Then we look for the parentheses. Since we don't have a backslash like that, that means I really want a left parentheses character. And then I look for the group, but the group starts with the hat, which is the not character. So this says an open parentheses followed by 0 or more not right parentheses, and then a right parentheses at the end. Wow, it's hard to mark that. Then a colon, and then the $sign is the anchor for the end of the line. And we're going to look in the file whatever.py. This is a fairly normal looking regular expression. It's not perfect, but it's a good start, and it would work for the sample programs we have. So let's get out of here and take a look at our sample programs. If you remember, those were in a directory called stuff, and I've modified ex4. Let's look at ex4.py. If we look at it with nano, it looks pretty normal, except that the spacing's a little different. But what you don't know is this file now has all those ugly tabs. Does it run? Yes, it does. And if we cat it, it looks normal. But there are special options to cat. Cat has an option called -T that's going to show tabs as that hat eye character. And now you can see, def and main are separated by a tab. Those lines begin with tab. This line begins with tab. So what's another way to look at this file? Because maybe you have a literal hat eye. How can you be sure? The gold standard is the hex dump. And you use the lowercase v and the uppercase z, C communist. Give the file name. On the left column, you have the offset into the file, the address. Then you have hexadecimal bytes, 16 bytes. And on the right-hand side, you have what it would look like in text in the file. So when we get down to this character right here between def and main, it shows a dot on the right-hand side. But if we count, that's 1, 2, 3, 4, 5, 6, 7, 8th character. So we go 1, 2, 3, 4, 5, 6, 7. 8th character is 9. Okay, 9. Hexadecimal 9. And you should know that that is the tab key. You can use an ASCII chart on the World Wide Web to learn that. But I've run out of time on this video. At least now you've seen the tabs and you've learned about regular expressions. So come back for the next video and I'll show you that our nice improved regular expression can still find this function definition. I want to thank you for listening, and I'm sorry I went 1 minute long on this video.